So, the new introduction that I want you guys to know is the mole. So if you have your notebooks open, you're going to copy this down, copy all this down. You can do it. So the mole, in the meaning of it is, of course, is this big number, this huge number that's written out right here, right? It's 6.02 times 10 to the 23. So this huge number right here is what a mole. Like the dozen that we were just talking about, the dozen, that means exactly 12. The same thing. The mole means exactly this huge number right here. Now, in order for you guys to see how big this number really is, like there's two things that I want you to notice. Is this. That if you see, what is this place right here, you guys? What is that place? Huh? The thousands, no? Hundreds are right there. That would be the thousands, right? So the thousands, right? What is this place right here? Millions, right? Good. Millions. So therefore this one should be what? Billions, right?
I can't see it.
The 9 zeros would be billion, right? And then if you go on 100 million, and I'm not sure how to get these numbers, but it's huge, right? It's like a billion magnitude, and and I heard somebody say also, like, if you would count, if you could count 1 second for one number and try to reach that number, like if you say 1, 2, 3 to match the seconds, right? How long do you think you can reach that until you can reach that number?
It take you the same thing.
It'll take you what? A day?
No, I take you a while.
A while? No.
3
How about
years?
3 years? No.
No, you said something.
3 years?
It
No.
was a year or something.
Not a year.
No, it was.
How much? How much do you think? Just give me bigger numbers then.
A decade.
Yeah, a decade? No.
More than a decade.
More than a decade, yeah, but a century, not even close.
Your life.
It's funny. It's like the life of the earth all over again, or beyond. Because you could never reach that in your lifetime if you start from 1 when you were born. If you start from 1, 2, 3, you would never reach that number. And then you would just be dead. If you take generations, you also couldn't. Because it's a huge number. If you're just going to go by ones every second, it's a huge number to reach. Now, why do you think we need such huge numbers to represent atoms and molecules?
Because they're so small.
Because they're so small. They're extremely tiny, right? Yeah, they're extremely tiny. Therefore, in order to weigh them, we need so many of them, right? So, the scientific definition of 1 mole is exactly equal to the number of atoms of 12 grams of pure carbon. So that's just scientific definition, like the STEP definition. It's based on carbon, the mole, right? And then it says we use the mole because, like you said, atoms are incredibly small and we need a lot of them in order to weigh them, right? So good. This is Avogadro's number. This is the mole. And the next step is, what does this mean in molar mass? So if you just copy all this in your notes. Molar mass means the mass of 1 mole of atom or molecule. Synonyms are atomic weight. So we have a few synonyms. We have atomic weight, we have atomic mass, formula weight, molecular weight, AMU, which stands for atomic mass. So there's a few synonyms you can call. It's the same thing, right? The molar mass of each element of the periodic table has been determined. Therefore, when you look for the molar mass of any of these elements, they have it in your periodic table as well. When calculating the molar mass of a molecule, just add up the molar mass of the elements that make up the molecule. Now, make sure, you guys, what is the difference between an atom and a molecule?
Atoms are small.
Atoms are small. Atoms are these tiny ones. Every single one of these is an atom. Now, a molecule is what? What's the best definition you can give me? Based on the atom, the definition for a molecule.
They're bigger.
Good. They are bigger. Because they're composed of atoms. The main difference, you guys, is just this. These are all atoms, right? All of these are atoms, single entities. You combine them to make molecules. So, can you see where H2O comes from? Water, H2O. You need what? You need which two atoms for H2O, for water?
Hydrogen.
Yeah, hydrogen
And oxygen.
and oxygen. Specifically, two of these and one of those, right? That's why we call them molecules, because they're made up of the atoms, right? Yeah, so just to give you what this means at the end, I have an example for the next slide. So we'll do that. We'll do that calculation. So everybody got this down?
No.
Oh, okay. And then we'll start our lab right now, you guys. Right after this, we'll start our lab, and I'll for sure I'll model the first part. Like it says in your lab, the first part is modeled, and then we can go ahead and do the rest.
You can go to the next one.
Yeah, right. Okay. We're good. Few more seconds. It's always a good skill to get it down fast again, because a lot of times you're gonna have notes where the teacher goes zoom, zoom, zoom. So you gotta always be good with that. Good? Good enough? Okay. So we're gonna move because you get it from your neighbor if you don't have it. Please. Okay. When they tell you this thing right here, sorry. This thing. Find the molar mass of CH4. What do you do?
And then,
You go to the bottom of your attic.
You go to the periodic table. Now, how many atoms does this have?
Two.
2 atoms, right? Atoms is carbon
and hydrogen.
and hydrogen, right? So, we have how many carbon? 1. Because it has an invisible 1 right there, right? Huh?
Is it color?
Oh, it changes?
Yeah.
Okay.
Yeah.
That better? And then there's 4 of these guys. Now, the periodic table says that this carbon, the molecular weight is about 12. So 12.0, right? Grams per mole for 1 carbon. 1 hydrogen, if you read your periodic table, is 1. Let's just round it out to the 10th place. If you're going to round it to the 10th place, you're going to get 12 and 1. Now, there's 4 of these. Therefore, you multiply by 4. 4, and that's 12. So the addition, because it's a molecule where the atoms are together, therefore there's an addition, you get 16 grams per mole. So the molar mass of CH4 is 16 grams per mole. So that's basically it. You just take them apart in their atoms, and then you add them up at the end, right? So that one's straightforward. And then make sure you guys, atoms are the ones, always capital letters, but then if there's a lowercase, that's also part of an atom. Capital letter, lowercase, or just capital letter. From all of those are just that, right? Now, one thing, we're going to go over this when we do the toast lab. What right now I'm going to model for you is everybody can take the lab out. You have this in front of you. So the first part, I'm just gonna model, and then you're gonna follow with me with this sugar, right? So before we get into this part, we're gonna go ahead, and then I'm gonna model this. How to help you guys use the tare in your digital scales, because that's important to know. So look. Once you have your digital scale, you just turn it on, and it should have a 0 reading, right? Now, if you ever want to measure anything, you first put the empty beaker in. Okay, you're gonna put the empty beaker, and it's gonna have some weight associated with it, right? But then, if you want to weigh something that you're gonna put inside, all we do is press the tare button. So the tare button, what that does is it goes back to 0. So anything else you add is going to weigh that. So that's why it's important to always do that. Therefore, we're going to add a mole of sugar. Now, I did the calculations yesterday, and the sugar. Sugar is C12H12O11. If you do all this calculation, right, you're going to do 12 times 12 for the sugar. For the carbon is 12. This is 12 times 1 for the hydrogen. And then this is 11 times 16. Can you guys tell me really quick what do you get if you do this? 12 times 12, and then plus 12 times 1, plus 11 times 16. And remember, this 16 I get from the oxygen, this 1 I get from the hydrogen. So, what do you guys get there? Let me check this one. What do you guys get?
304,000.
304,000?
128.
Actually, I got 332
Yeah.
grams per mole.